Everybody, it's Tyler here at Chesney Chance, checking out team number 6328, Mechanical Advantage, coming in from Massachusetts. And we're with Maddie, Mike, Lizzie, and Jonah. We're going to be going through this awesome robot they have. I love the aesthetic design. It actually gives me a little bit of reminiscence of a 254 2013 robot with some of this cool climber going on. So excited to see what's going on with this robot. All here coming up on Behind the Bumpers.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
We'd like to thank Stryker for their continued support of First Updates Now. Stryker's internship portal is now open and available. Discover internships and rotational programs located around the world, including their headquarters in Michigan, when you go to careers.stryker.com and click on Students and Graduates. We'd also like to thank Kettering University. Kettering University is where robotics students come for their education. Over 30% of those who attend Kettering University were in high school robotics, and you can keep going with their BattleBots, VexU, esports, and First Mentorship programs. If you are a U.S. student grades 8 through 12, scan the QR code to stay up to date on info and events happening at Kettering and get a free Kettering t-shirt when you sign up by December 12th, 2021.
So starting on this robot, we're going to be talking about that power cell journey, starting with your intake here. Tell me a little bit more about some of the inspiration, thought process behind it, and of course what goes into it as well.
Sure, so this intake is actually brand new for this competition. We just finished assembling it a few weeks ago. So you'll see it has 4 bars, and it actuates out with these 2 pistons. Hunter, do you want to demonstrate? Just like that. And then the ball path goes up over the bumper. Yeah. Like that, and then you'll see that we have vectored Omni wheels on both sides with some sticky wheels right here to really grab the balls and suck them in as fast as possible. Now this is all powered by 1775 right there with a custom gearbox. Next up, after the intake, oh yeah, and that's right, we have these Lexan pieces just to stop the balls from flying out, as well as these like guitar strings, because the balls have a tendency to pop out before we put them on. So next up, are we ready to go over to the hopper with Mike?
Sure.
All right.
All right, so after it comes through the intake, it goes in the hopper, which is run by these 2 belts here that kind of guide it into the shooter. And it can hold around 5 balls in here as well, and we just have these little side panels to keep it inside here.
So on this hopper here, was this kind of like a second iteration or something like that, or like did you initially have it where the power cells were going to be kind of enclosed this way, or did you kind of have to iterate to get to that spot?
Yeah, we kind of knew we were always going to have like a cage around it, and it just took a little playing around. It was really hard to bend these pieces to get them where we wanted to. We started off by zip tying these together, but we ended up just doing these bungee cords across just because it was easier. So, and yeah, that's the hopper. And so after that, we can move on to the shooter.
Yeah, tell us more about it.
So the shooter here, it's 3 pairs of wheels over here that kind of guide the ball up and compress it. And this hood back here, and we have this adjustable hood that is 4 stages, so we can shoot basically from anywhere that's legal around the field. And so Hunter's going to show the 4 stages.
Yeah, so looking at this game here with the different stages on it, what made you choose like a pneumatic for adjusting the hood versus doing it mechanically?
We just decided it would be nice to, have these set locations to where we could always go up and have the same distance every time, or have the same hood adjustment every time. So
yeah, I love the overall aesthetic design that your team is having as well too. Let's move on next into the climber. I think Maddie, you're going to talk a little bit more about that. As well too. This climber is a beast. I'd love to see more about this, hear a little bit more what went into it as well.
Yeah, I'd be happy to. So we have dual climber arms. Basically the way these work is you can see we have surgical tubing lining around here with a small piston. So when this piston pops out, there's a little hole and it causes the surgical tubing to pull this up. We just have it at an angle so we can fit under everything and within frame perimeter. And then when this pops up, it also releases our extra 2 stages right here. So you can see we have constant force springs right there. That cause it to want to pop up. And then we also have, if you look down, you can't really see it right now because these are angled, but we have a winch powered by this 775 that when these pop up, it pulls them back down.
Are we able to see the climber deploy at all? Can we check that out?
Yeah, for sure. Everyone just step back. It's a little fast. Hunter?
I love it. That's just so awesome. And the way it kind of just rotates up nice and easy like that seems like really easy for drivers.
Yeah.
From a climbing perspective on here too, I mean, these look quite robust. I'm assuming like if you need to, you can probably just climb with one arm or something like that. Does that work for you?
Yeah, we've had to do that a whole bunch.
Okay. Might need to talk to your drivers about that part, but yeah.
Yeah, especially just because of the angle.
Yeah.
You know, sometimes it's kind of impossible to climb with two arms if we're climbing at a very steep angle. But yeah, they've worked really well for us so far. They have been quite robust, which we weren't completely expecting. Again, we're really happy with them. Yeah.
So a couple last things to wrap up on your robot. Talk to me a little bit about your drivetrain, what's going into that. Looks, pretty standard like West Coast, 6-wheel West Coast. Anything in particular you want to highlight on it?
I'd be happy to talk about it. So our drivetrain is a standard West Coast drive powered by 2 Neos on each side. And then we just have, your typical chain. We bounce back and forth a lot on wheels. So we started with a lot squishier wheels. We moved to like treaded wheels where you can take the tread off, and then we ended on these pneumatic wheels, which this is kind of our second time using them in competition. We used them in Battle Cry a few months ago. They've worked well for us. We've had to replace them once. But yeah, it's been all good.
So Jonah and Lizzie, I don't want to leave you two out either, of course, from a programming and electrical standpoint. Anything that either of you like to highlight on this robot as well?
Well, one of our focuses this year in terms of programming was on odometry and vision. We want the robot to always know where it is on the field. So here we have a limelight in front of the shooter, and the robot is constantly trying to search for a target, which it's doing right now, and zero itself on the field, then track using gyro and encoders on the drive where it is. So we always know the distance to the target to select flywheel speed automatically, and we can choose a hood position based on range. One of our latest additions we can see over here is some basic logging of odometry data. This is an auto we were running at a previous event. So we can see where the robot thinks it is, and here the green line indicates when it re-zeros based on vision, so we can confirm everything is working correctly.
Well, I look for that 100% accurate shooting, of course, during this competition out there. As we wrap up on this, anything electrical-wise, want to talk about any packaging or anything like that that you put into this robot?
So actually a majority of our wiring is underneath the hopper right here. And so you can't really see it.
You're keeping it hidden for Chessie Champs, I understand. So
we have the battery, the RoboRio right about here. And so because we have to take this on and off a lot to get to the battery, we had to play around because there's lots of CAN connectors right here. So we played around a lot with the connections, and we used locking and a bunch of different things to make sure those were secure. And we also used a Swift board on the RoboRio to make sure everything stayed secure. That's pretty much it for electrical though.
Well, 6328 Mechanical Advantage, thank you so much for taking time to speak with us here at Chessie Champs. Looking forward to see what this robot can do. So good luck at this competition. I can't wait to see your robot compete. If you got any others, but of course feature season as well. Thanks for taking the time.
Thank you.
Thanks to Kettering University for their support of this video. Don't just sit in class. Kettering University is the only school in the U.S. that allows you to work as an engineer your first year with their 3-month on, 3-month off co-op programs. If you are a U.S. student grades 8 through 12, scan the QR code to stay up to date on info and events happening at Kettering and get a free Kettering t-shirt when you sign up by December 12th, 2021. We'd like to thank Stryker for their continued support of First Updates Now. Stryker's internship portal is now open and available. Discover internships and rotational programs located around the world, including their headquarters in Michigan, when you go to careers.stryker.com and click on Students and Graduates. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.